Thanks everyone for joining us here today for the third edition of the WHRI Lunch and Learn series. Just as a reminder to folks, so this is a monthly series we're holding virtually, and we do have a new tab on our website under news and events called Lunch and Learn, and this is where you can follow along for all of the upcoming sessions. So Sabina will be hosting our session today and as well as the one in June. And then I will be conducting a lunch and learn in July on knowledge translation. So I'm Nicole Presley. I'm the knowledge translation manager here at the Women's Health Research Institute. And if you do have any suggestions for topic areas that you'd like covered, feel free to either pop them in the chat or email them to me. Before we get started today, and I pass the mic over to Sabina, I just want to acknowledge that we're joining you today from the traditional, ancestral, and unceded territories of the Coast Salish peoples, and this includes the Musqueam, Squamish, and Tsleil-Waututh nations. And I'd like to acknowledge that I'm an uninvited guest on these lands who is engaging in my own unlearning and learning journey. And I invite you to acknowledge where you're joining us from today in the chat if you'd like to do so. So with that, I will pass the mic over to Sabina, who is going to present the data life cycle.
Hi, guys. So I'm senior statistician with WHRI, so probably know. And this is the first lecture in my Lunch and Learn series. I think I planned about 10, but I'm not close to it. So this is about data life cycle. So if everything in our life, the data has a life cycle as well. So it's going through certain stages through its existence that if we know the stages and understand how those stages work and how it's connected, it will help us to get the best data possible we can aim to. So the learning objective of this series, like understanding data cycle, can help us to avoid the garbage in, garbage out situation. So basically, if you have the data, you'll probably have better analysis, and we cannot infer it to population or make decision based on this data because it will show us sometimes results that we don't expect, or it's really weird and it can happen. But I learned from my 20 years of experience, if you work through the data step by step and all the steps are organized and planned, you usually will not have garbage in and garbage out situation. So data cycle is basically all steps the data undergoes. So I talk about a little bit about planning, production, description of the data, how data should be managed, pre-process, and also what the data governance policies can be implied within any projects. So also what's important for us as we work in healthcare is data privacy. So data cycle also allow us to relate to data privacy procedures with the organization we work and understand how, what we should do at any step of the data pre-processing or analysis, how the data should be identified, or other data privacy policies should be applied. And also in statistics, there is two main aspects. It's usually probability and uncertainty. But what we mean by uncertainty in statistics is statistical uncertainty. It's uncertainty we introduce by using sampling or other modeling. But if our data is not shaped in good, if our data are not good, so basically we can introduce additional uncertainties to only statistical uncertainty and bias our results. So going through data cycle processes and procedures can help us to remove unnecessary uncertainty and help us to predict the likelihood of future events based on our research questions. So about me, I'm really passionate about the data and statistics, and I also think the data is a commodity. So data have a very high value. So if you use the data correctly, we can benefit from it a lot. And one of my favorite citation is, information is source of learning, but unless it is organized process and available to the right people in the format for decision making, it is burden and not the benefit. So our goal as a health professionals, so people that affects in other people's life by our research, it's very important so that whatever we do with our data of our research will benefit people around us. So this is basically our main goal probably. So as English is not my first language, I'm always confusing between what is data or what are data. So I went through several data dictionaries, and as our time changed, most of the data dictionaries actually say that you can use both. So I think when I write, I usually will write R, but when I talk, I can interchange. So basically, to know about me more, you can look on Oxford English Dictionary explanation. Basically, says can use both, but traditionalists do not like to treat it as singular. So basically, I prefer to use it as plural because I also learned UK version of English at school. So what is data cycle? Data cycle is basically all steps that we go with our data. So it's starting for pre-planning of our data. We have a plan, we have a research question, we need to figure out how to collect our data. When we collected our data, we received our data, we must assure the data is okay. So we need to validate data, make sure there is not a lot of missing and other issues to basically that what we planned and what we collected, I match. After that, we need to describe our data, but it's not all our descriptive analysis statistically, and actually we need to describe our data that other people that not familiar with the data can use. We need to preserve our data, so we need to be clear when data is saved and who can access the data in each step, so different steps. After that, we go to discovering our data. So basically, we're learning about our data, we're describing what data we collected. So usually it's part of descriptive analysis. After that, we go into integration. Integration, sometimes we have different data sources like survey data and administrative data. We need to figure out how we combining different data sources together. And at the end, we are analyzing our data, writing our papers, writing our reports to stakeholders, social media and everything, and we share it with other people. And what is important is that all stages of our data cycle are related to data security and confidentiality. So basically, when we plan the data, collect data, discover, we need to be sure we using appropriate methods, laws, and like rules appropriate for organization we work with. So what is data privacy? I know we all know about it, but actually only we kind of see the data privacy, what we collect, but actually data privacy about what other people or we as a people want to share with about us. So basically, it's important for me, like I know that by BC law, administrative data can be used without consent. Yeah, people just submit ethic application and can request from POP Data BC or Ministry of Health data. But it's important for me to know the data about me used in proper way, so that my privacy is not compromised above the scope of the research. So also, apparently there are countries where privacy not considered a fundamental human right, but fortunately in Canada it is. We have laws about the privacy. And there is the fair data privacy policy. So basically, it allows us to do our research, but there are certain limitations. And also, it limits the qualities of the data or purpose of data, because we cannot collect everything we want. So we need to compromise of what data we can get. there is limitation how we can use data we collected based on the approved ethics and so on. Our data should be securely located. And also important part of data privacy policy, and I know some of the grant agencies requesting it, so your data should be open. So some of the, like I know NIH request for you to have open, to share your data for certain part of the research. And also we need to have accountability of that or about our data. So basically what we collected, be accountable of what we're doing with this data. So as we work in PHSA, actually on PHSA websites, it says that PHSA is working based on the Freedom of Information and Protection Act, FIPA. And it's saying actually, it's granting access for information for researchers and patients. I understood that if I'm a patient, starting from January 2007, I can connect to PHSA and request some of my records and see how my data was used. But it also protecting the privacy through all stages of the data collection, use, disclosure, and protection. So basically everything we do, we're doing based on FIFA and data privacy. It's why, for example, when you send me the request, I will ask that the data will not be shared by email, but only through HTTP server of OneDrive through secure channel. The data will be identified, and as a suggestion, it's just to follow the privacy procedures we have in here. So the first stage of the data cycle is plan. First of all, before we collect information, we need to plan it. And it actually, I think, is the most important stage of our data process. So what we need aim of the research. Aim of the research, we need to be 100% sure or 99.9% sure of what is our research question, how we're going to answer this research question, and how we're going to get data to answer our research question. And if we're talking about the research question, there's in literature, there's something like strong research questions. So it should be very specific. We need to know exactly what we're asking. It should be feasible. So basically we can do any research we want, but we need to understand that we have money, time, availability of data and other constraints. We need to make sure that whatever we want to research is feasible, we can do it. It's good that our ideas are original. So sometimes we would like to reply to other people's paper or research. So our idea will be not original, but usually for most of the research, we have some kind of new idea and we want to develop it. It should be relevant for the field we work in. So for example, in health, we're not going to do probably research about, I don't know what, about history, although we can, or something like not related to the data. And our research question should be complex and arguable. So basically, it can be very complex, but usually goes that if we can write a paper and fit what we want to ask or our question in the scope of paper or project, it will be complex enough. And it's also arguable. So basically we can answer to all the questions about our research. We know what happened. We can have different results from our research, and we need to understand what's going around. And of course it should be focused and researchable, because if it's not, it will be very hard to collect the data and answer the question. So we all know that there is different type of questions, and Julia talked about qualitative analysis at the previous lecture. So basically there is two types of questions. It's qualitative or quantitative. My experience of quantitative. So usually quantitative data is more precise. We can answer to different hypotheses based on this data. We can describe this as data. We can compare. We can do modeling and relationship. Qualitative data is measure actually other characteristics that we cannot measure by quantitative analysis. It's more interpretive or adaptable, and it's not so direct as like numbers. But I think, and I mentioned about it multiple times, the mixed research method where we combine both questions, it's probably the best because it will help us to answer our research questions in the best way possible. So we planned our data, and another thing we need to know which data source we're going to use. So generally there is two major types of data in qualitative analysis. It is the primary data or secondary data. Secondary data is usually much cheaper. It's data that someone already collected. Usually it's not so complicated to access it. It costs less money because data already collected. We don't need to spend resources on it. But the problem with the data that it's not necessarily will be specific for what we want. So usually there are some variables that can help us answer our question, but they're not exactly the same as we want. So we will need to use as a proxy or adjust our research to fit the data sources. The primary data sources is usually something we collect. So we plan it, we collect the data, we have more power about what we're collecting. It's usually real-time data, and we're very involved in the process of data collecting and planning. The primary data is usually surveys, observations, experiments, different questionnaires, personal interviews. It's expensive because we need to use a lot of resources to collect primary data. It can be very specific because we can structure our survey or collect data specifically to the question we ask. And it can be more accurate because it includes information that we planned and wanted to use. It's not the proxy. We know exactly what we're going to collect with primary data. So this is the questions or objectives that we need to think about when we plan our research, like which type of data we're going to use. So assuming we decide which data we use and our project went ahead, it's very important also plan how we're going to structure our data. And I can give you different examples. For example, you collected information from two different hospitals that doing treatment to same diseases a bit different way. And if you would like to compare those two sites, it will be much easier if the data for those two sites will come in separate tables that we can combine. It takes space of the computer. It also can have different variables named for the same things and a lot of different things. So it's much easier to treat those two data sets separately and only combine them when we doing actual analysis. So the most common, there is a lot of different types of data and big data and everything. But for health research, the most easy and affordable and simple way of structure the data, it's actually rational database. What is rational database? It's basically you Excel and Access that you can use. So you have different tables for different questions. Those tables, as on the picture, are related to each other. So basically, we can have 50 tables, but tables are structured in the same way that we can link them using the unique identifiers. So all the data we collected in different tables, it's linkable. So as I worked mostly in transplantation previously, and I like to give example, for example, for transplantation, I will have one table for patient information and another table for donor information and table for transplant information, what happened to person during the transplant. And I will have additional lab tests for this person or medication. So each type of data should be kept in different table with minimum information, because if we can link all these tables by mix and match, we can create our final analytical file really fast, and we'll know where all the information is saved and how to combine it together. And also for me, rational database usually very intuitive and straightforward. We can easily divide our information to tables. And basically, your rows are usually your ID, so patient, it can be cross-sectional, one record per person, or longitudinal, multiple records per person. And your columns, it's actually your information that you collected, your data, sex, gender, age, and so on. So we decided what data we're going to use. We structured the data to tables. Now the next stage of the data cycle, we actually need to describe our data. I usually describe our data before I put it in tables, but it depends of what data we have. For example, if we get some data is secondary use, we will receive the data dictionary for it. So there is no a lot of room for us to describe it prior. So to describe this data, we usually use metadata. What is metadata? Metadata is data about data. So basically, and in order to create our data in a specific way, we need to know what is our target audience, because I can describe data with a lot of details and too many details. So in my, like when I work in my metadata, I can have type of data and format and sub-format and a lot of other information that might be not needed and interested to other people for their purpose of the research. So I need to decide when I create the data about my data, I need to know what documentation, what I want to include, and how much information I want to include in metadata, because we can sit for 2 years describing our data and not doing research. So there should be some kind of balance, enough information to understand our data, but also not to spend too much time on doing things that we don't need to do. So basically, what is metadata? It's not all documentation about the data, it's only specific subset. It's usually very structured and there's schematics in it. So there is a description of all the categories for each variables, a description of variables, what the data tables we have in the data, how they link and so on. And metadata can be part of the data management plan. And I know from my experience, some of the agencies where we submit the grant actually will request the data management plan, especially, for example, if you work in clinical trials. For clinical trials, usually we should have data management plan. And they say, like, this is, I found on the web, we usually don't use it. Data depository with paper submission is required. So basically, in my understanding, that we have documentation to the data and data associated to the documentation, because I had situation when I received the data with data documentation and data dictionary, but data dictionary whatsoever was not related to data I received. So basically, data should describe exactly what we have and not what we might have. So another principle of data, it's fair data principle. So fair, it's not like the word fair. What I think that it's fair for everyone. It actually stands for findable, accessible, interoperable, and reusable. So basically, when we preparing information about the data, it should be structured in the same way that it's easy for us to find information we need to find. So for example, list of variables associated with the table. If I need specific variable, I will know which table to look. Accessible, it means metadata should be created in the way when it's understandable for humans and nowadays for machines as well. For example, for me, it's very important that it's understandable, because I can create macros or programs that will read the data dictionary in specific formats that I can use in my program. So if it's structured in a specific way for computer, and for me, it will be very easy to understand. Interoperable, it means the metadata has a very formal language, but it's very understandable and we can share it easily, and it should be written in the language that everyone can understand that work in the project, because not everyone will familiar with data, but they need to understand the documentation we're providing. And data should be reusable by creating data in structured way, for example, as a rational database, and having decent metadata. it gives opportunity to other people to use our data in really easy way. And of course, it's good to know what is your license. For example, I can program something for myself or my home, how I do my, I don't know, expenses and budgeting. I can download free license version of the program and do it for me because I don't sell it, it's usable. But if I want to sell my program, I need to use different license. So it's very important to also know which programs we use and when we're working with the data, what license are applied and how what we can do and what we can't. So we have our data, we have our structure and basic documentation. In a lot of cases, especially when the project is large, it's very good practice to have data management plan. So data management plan is describing what data we have, what sources of the data. For example, we can have survey data that will be linked to administrative data, POP data PC. We need to include documentation of our data, metadata. We need to know how data will be stored, how it will be backup, what the security we have, like firewalls and everything, like data should be behind the PHSA firewall or something like this. We need to state directly what is our what privacy policies we're going to follow, how data will be identified. For example, usually data analysts can have access to personal information and more data, but specific researchers will receive only subset of the data related to their analysis and research. And it's also usually good to say how we archive our data. For example, some of the grants say that you need to keep data for 6 years after research is done. For example, I work in organizations that we were not allowed to keep the data, but combined public use files were created and sent to Stat Canada to keep. So data was completely aggregated, identified, but still usable. So everything, all those aspects of the data are written in the data management plan. Usually for big organizations, there is data managers that will create it, and the data manager will assure that everyone using the data management plan as designed and all stages are followed. So now I talked I know like lecture a bit complicated because and a lot of information, but now I'm going to go to more details. So I'm going to talk about data dictionary. Data dictionary is basic type of metadata. It's describe information about specific data that you have for your project. So data dictionaries, there is some cons and pros. So usually in data dictionaries, you don't describe a lot of functionality about your data and how everything linked. And you cannot visualize it, you cannot do it really fancy. And it can be sometimes very difficult to understand. The data dictionary can be difficult to understand, but persons that don't work to data. So it's kind of, but it provides organized and comprehensive list of information we have. It's also giving us some reporting and documentation, especially if we're using data through different data platforms. For example, I'm using SAS, someone else using R. The programs are different, but data dictionary will help different team members to work on different applications in different ways, but still in the end, we can combine information together. It's usually very simple and very structured. And it can help us to maintain integrity across multiple databases. But basically, data dictionary is the simplest and easiest way to describe our data. So also, when I do the data dictionary, especially for the new project, when I try to describe the data, it's usually understand each variable in our data set, not just describe the variable, like string variable, character variable, numeric variable, categorical, dichotomous, continuous. It's also good to know how these variables will be used. For example, this is one of the tables that I submitted when I requested data from visit transplant, for example. You not only submit the variables you want to receive for them for your analysis, you also need to tell them what's the rationale, why are you asking it. It also can be used as part of the ethics application. So here, for example, is basics table that says, this is the baseline characteristic I'm requesting from you, and this is how I'm going to use it. So for example, most of the variables will be used as covariates for adjustment or stratification for modeling. Postal code can be used at GIC for mapping and associating information with different health region and so on. So it's very good, not just collect your information, but also know how it's going to be used. And it's directly related to data privacy when we say we only can collect the information we need. We don't need to collect information that is redundant or can compromise the privacy.
Lori has her hand up.
Sabina, yeah. Lori, did you, I see.
Yeah. Hey, Sabina, just a quick question. This is great. If you can just go back when you are requesting the data dictionary from people who are asking for your services, do you also want a column that tells you exactly, the scales for that particular question and how it was, dichotomized or labeled? So for example, in the gender column, they'll put 1 equals woman, 2 equals man, 3 equals gender diverse. You want all of the value labels as well within your data dictionary?
And actually, when people ask me how to submit information for me, in SOP, there is detailed part of how data should be submitted to me. And there is template for data dictionary with examples. I actually ask several PIs I worked with if I can use description of the data of projects I already used and modify the data as examples. So it's exactly the same. So basically data dictionary for us, it's very simple, an Excel sheet with 2 subsheets. One will say what is the variable name and what's the label, what this variable name means. And the second one is basically in SAS it's called formatting. So if you use in Likert scale, it will say like 1 very dislike and 5 very like and so on. Yes. And in SOP also, there is different other rules, like length of a variable shouldn't be more longer than 20 characters, because for example, SAS not handling more than 25 and it truncates the variables and can be a mess. And also it's explains convention of data variables. So for example, usually you don't use dash, you use underscroll. You can decide through your project, you can decide like section number A, question number Q1, underscroll and the name. So basically the variable name should be very short and very self-explanatory. So when I look on variable, I actually don't need the label. I can understand what approximately it is. So it's everything is saved on our website under statistician services. There is all the templates, SOPs, and statistical request form. And if someone needs help and don't understand something, they can always contact me and I can have a meeting and explain.
Sabina, Beth just made a good point about REDCap, and I know that there's probably quite a few folks on this call who use REDCap. I just wonder if folks mind putting up their hands or just a thumbs up if you primarily use REDCap for your research, because then we can see how many of you there are on the call. Because Beth reminded me that REDCap does have an automated data dictionary function. And so Sabina, I wonder if even in follow-up to this, what we could do is a little blurb or communication to folks if you see a red cap data dictionary.
It's not a data dictionary.
Okay, so maybe what we can do is send some commentary about
How to convert that into
how to
a
convert that
usable
into
format.
yeah,
No,
that might be
for me, why not say, like the way I designed this data dictionary?
Yeah.
I design it in the way that if I need to program something into analysis, it's very easy for me to use. Yes? So I have one column, 1, 2, 3, in other column, what it means. So basically, I can load it in my program in specific way, format all the variables to get the analysis. The way it's done in a RedCap, I need to actually to report everything. Like I cannot use it automatically. For example, you have one male, one female in one line, click 1 dash female, semicolon or like column, I don't know, and men. So I cannot, I want it to be not in one line. I want to be for each different column. So I want it to be exactly as I put in data template. So people that submit me data from RedCap, they actually need to redo the data dictionary. And I read, and actually, I'm really sorry, guys. Until now, the data from RedCap I received for small projects, it's not data. It's not structured correctly. It's very hard to work. It's really hard to understand. You have like 50 variables in one table. It's not designed in a relational database. It's really hard to find something and navigate. It's why actually I decided to do this lecture to help people to understand how to structure the data better.
Yeah.
Like right now, whatever we have, we need to deal with it. But for the future, if you plan the data for your future analysis, even if it's small analysis and small sample size, it's really good to structure it in a specific way. And I also said in my first lecture when I offered my services that if people need to design this database and have questions, they can come to me because I developed several information management system and program before, so I know exactly what I want to say in the data.
Thanks, Sabina. Yeah, we see some commentary about RedCap in the chat. Thanks, Travis.
I personally don't like RedCap. I don't know why people doing service in RedCap. There is much better software that can be used, but it is what it is.
So maybe what we'll do is we could send some follow-up commentary on data dictionaries. And I know Sabina, we do have the resources on the Our Services page, but if there's other more tailored information we can send to folks, we can always follow up with that.
Yeah, and actually our plan, and I know Heather can confirm, we talked about it. I'm waiting for new projects that will be developed for RedCap. Actually, we are planning to do SOP or detailed explanation how to put that in RedCap in correct way. So it's easy for us, but it will take time because there's no, it doesn't make sense to do it on the old project, but I think if you have new projects that plan to put that in RedCap, we can structure everything in advance and we can validate it later and adjust. So it's in my to-do list for the future.
Sounds like maybe a nice collaboration between you and Heather.
No, we already talked about it.
Okay.
And actually I got the free account for RedCap, but I didn't have time to play with it, so.
Okay. Thanks, Sabina.
Like
Sorry
I usually design my own applications and databases the way I like it in my specific way. It's not maybe the best way, so yeah, we need to adjust. So basically here we going to the next step. We already collected information and put everything and did the documentation and organized everything. Everything is cool. But now we need to process our files. So, and also I learned the hard way, when you cleaning, basic preprocessing means you cleaning your data or creating your analytical files, it's actually should be structured. I know I'm very structured person. That should be structured in very good way so we don't lose information. And I can give you several examples. For example, I work for the project. The data was extracted on one day, person runs the analysis, I got the nice tables, and someone come to me and say, oh, in the model, we want to add additional variable and see what we get. So I'm going to the program, I'm running the program, and I'm saying to my boss, I'm very sorry, but something happened to our data because I ran it first for original model, and actually my results are different from the results you submitted to the client. And they say, how come? I said, probably someone overwritten data, and it's like newest version of the data. We don't know what it is. And it was, let's say, go figure who overwrote it, when overwrote it, because yeah, I know on network you usually can pull the previous version, but you cannot pull the previous version 10 years back or 5 years back. So we dealt with that in a very politically correct way. We come up with the idea how to not to do anything and stay client. Yes, this is what we're going to get. We checked and nothing. It was true, like whatever they wanted to do was not relevant. So we come up, but generally until now, I think no one knows what's the data. So it's why you need to work on your data. On each stage of your data, you need to create permanent files that actually not in your program, but actually saved on the network drive. So you know that this is the final version of my analytical file. And if you change it later, you just change it with new date. So you know that, or any versioning you using, I think everyone has their own like procedures, how to version, how to save information. But basically it's very important to save your information in the way that is reusable, and everyone that use same data set from the same date or from same analytical file. Like if you have 5 people running the analysis on the same data, they should get same results. Yes, so in order to do it, actually it's not in data cycle, it's from my own experience. And for several projects I worked, it worked very well. So there's different types of data I use. So the raw data is data I receive from any researcher or client. After that next stage, it's raw clean data. So basically I can redesign categories, I can label information, I can check the data, I can flag the data, but I don't change anything in the original data. Like I just beautify it. So it was some kind of data, I made it beautiful. I formatted, labeled it, organized it, divided maybe to different tables or combined tables, but I didn't change any information. And this raw clean data, you can see it in the like blue. This raw clean data can be transferred preliminary analytical data set. So basically, again, I can change a bit structure of the data. It was cross-sectional. I can like transpose it to be longitudinal. I can do a lot of things, but I'm not changing, I'm kind of transforming the raw data for something very analyzable, but this is still not my analytical file. What is my final analytical file? When I know the research question, I combine different raw clean data or transfer preliminary analytical file to create my final analysis file of files. So I think based on my experience, if I work in this way, it's really easy to find information. It's really easy to create your analytical file. And it's in each stage of data pre-processing, I know exactly what happened. Also, it's very good practice when you clean the data, you document all your decisions and what you do. For example, I decided to combine unknown and other. I say I have like document. It's look like the data management plan when I say in this file, on this day, I decided to do A, B, C, D, E, F, G. Because after that, if someone asks me what decision I make and why my numbers in analysis I provided doesn't match with raw data, I can explain one. So for example, there is imputation of the data sometimes, or sometimes you go back to client or respiratory manager to verify some information. So everything you verify, everything you do with the data, when you're preparing the data, you need to document. And my documents, like when I prepare data, from scratch, my documents can be like 100 pages. Like for each data set, everything I do, I document. So after that, no one asks question why the decision was made. And in some cases, for example, if information will be validated, I send this document to person that should validate and I say, this is my question, what you clinically we should do. This person should reply in this document, so it's a track of all things we're doing with the data. I should hurry. So basically, and because we talked about data, about privacy, so usually I create master person. It's like for each person, like for example, I have a list of PHN, I create random IDs. And if someone wants to create random IDs, you can contact me. There's algorithms on how to create random IDs. So if you have random IDs 1, 2, 3, 4, 5, it's not random. So when you de-densify the data, you should apply specific algorithms. It's really easy. You usually take some random number and modify this random number, but there's a way to de-densify your data randomly. So basically, it's very hard to track back. And so I have random IDs from one side, I have PHN from the other side, so I can link file. And based on this link file, I can identify my all data sources. So I had situations where data was de-densified using different link files, and actually it was unlinkable back. And usually it's normal practice that only one person has access to linkable data set, and it's usually like data analyst to data manager. And for example, if you work with POP data PC and POP data PC merging your data, the link file is going between POP data PC data manager, but there is a step when POP data PC will ask you to destroy the link file. So the information is not linkable anymore. So again, like this is we can like this lecture will be recorded. So basically, this is describing the processes what to do with raw data. Yeah. So raw data should include all elements from study protocol. So if you send me data to do analysis, I need to have all the variables that actually you want to use. I don't need to ask you, oh, where's the sex or where's the gender or something else. All the variables should be described. And as I showed, the table should be rational for a statistical analysis plan or proposal, which variable, what it will be used for and why. And it can be, we can have multiple raw data tables and it can be linked in any way. So raw clean data, again, all variables should be transformed to numeric except as I specify. Why? Because usually if you using same program over and over again, like I call it macro, function, or procedure, or whatever, if you're using it in a numeric way, you can use same program for multiple analysis. So it's why, and it's also if you have large files, it saves you time of running your program. So for example, I did one test. I had programs that was running on the server for like about 8 hours. I tried to run it with numeric variables and string character variables. And actually by using numeric, I saved running time like really dramatically for a couple of hours. So basically, when we creating raw data, clean raw data, we using for any outliers, invalid values. For example, if I have EGFR of 1000, it's kind of invalid, it needs to be validated. You're reporting how many missing values. For example, if you have variable with 80% of missing values, you probably say you're not going to use it and so on. So transform analysis file, it's, as I said, it's modified raw clean data set when we can change the structure and do any other modification. We can divide it to table, combine to table. We still keep most information the way it was. We can change data types. For example, we can combine categories. We can we can decide that continuous variable not the best fit for model. We can add additional categorical variable and so on. And mix and match of all data sets we already creating. We're doing specific final analysis files that tailored for specific project. So this is basically example. It's actually from my data management plan for transplantation project. So basically it's a plan. So we submitted request to BC Transplant. They extracted the data based on our request, based on ethics and proposal and so on. They transferred the data using FTP protocol. A password never shared by email. So if data is password protected, you actually should call person or communicate another than email way to give the person, because you cannot send the data and send the password in the next email. It's very unsecure. So usually when I received original data, I saved it as is, it was saved as CSV or Excel. I don't touch it. After that, I reviewed the data and validated data. And I prepared different data sets and preliminary data sets and final. So basically, this is kind of pre-processing pre-processing process that can be done starting with receiving the information. And also, this is example of how you can divide the data set. So for example, for transplantation, I can have pre-transplant information. So it's how long people were on waiting list, what dialysis what type of dialysis they had, for how long, how many previous transplants they had. I also can have transplant information that will be divided by information by patient, donor, or transplant. Patient information will include like social economic characteristics, different comorbidities, relevant infections. Same for donor. Transplant information will include specific transplant related. If they have delayed graft function, like cold ischemia, time for how long kidney was out, and so on. And after that, there is post-transplant information. So basically my post-transplant information included after transplant any biopsies, any rejections, all lab data for EGFR infection and so on, and any medications. So I received data in different ways, not necessarily structured like this, but I decided that this structure of the data is the best if I want to create final analytical files. So basically, to summarize, I think, so this is basically show you how data storytelling and data lifecycle can be exchangeable and related. So data storing is powerful tool. And actually recently I talked with my friend, she said, oh, I attended this conference where a guy was showing us data visualization, and asked us how we can tell the story. And she said it was very interesting because we actually told a lot of different stories. But what is important, it's an important tool, but when you present the information as you taught it, and basically the chart or table you're presenting should explain only one story. Otherwise, it's not so storytelling. Data storytelling is a very, very important part of knowledge transition. When we analyze data, publish the papers or reports, we can take this information and transform it to knowledge. And data storytelling can encourage innovation and boost efficiency. I don't know, I think it's true. It can exchange stakeholders, and one example is about like contraceptive medication for free. So basically it starts a project that told very nice story and is transferred to policy. So storytelling, to tell a story about the data can be powerful to engage stakeholders and change policies. But also when we try to tell a story, it should be very suitable to a target population. An example, for example, in a statistical table, I can present every mean and standard deviation of price of the houses in Lower Mainland. But if I go on website, I probably should say average house pricing or something like this. It's very important how we present our information to specific target group. And how this data storytelling is related to data cycle. Data cycle combines the best practices, production, cleaning, description, protection, governance processes of the data. So basically, if you do it correctly, it's reducing uncertainty and unnecessary bias, and we can tell our story better. It's also life cycle procedures help you to create the best data possible, to tell the best story possible. And if you organize the data in very structured and organized ways, it will help you to reduce any future uncertainty, and it will help you to do your analysis and predict likelihood of possibility of events or policy changes or results in much better way. Thank you. You have 5 minutes for questions.
That's fantastic. Thank you, Sabina. You're getting lots of applause here. I see lots of hands clapping.
And if people have like any questions, or the team members have any questions, you always can email me. I'm pretty.
Heather has a question in the chat. Do you have guidelines for file naming?
Yes, I do.
Of course she does.
But
is that a resource we can share with folks?
We can share. Well, I think it's very subjective. What is very like, basically I can share probably. So basically this is how I structure my folder when I do analysis. So you have a lot of information here, just general information. I don't put it in any folders because it's not a lot of information. So I have scripts. So when I do the scripts, I do very self-explanatory data name, data preparation intraoperative outcomes, data preparation outcomes, post-press. So it's very hard. And I also put the number in front. So it's saying basically if I'm not here and someone needs to run my program, they know in which order to run it. So you see, like if it's analytical file, I always write analy intro, or analysis, something to say that it's final analysis file. If it will be not final analysis file, I can say raw underscore, but it's up to you how you want to, different people like different things. So, but my analysis is very structured. So I don't need the data management plan for it because I know where is everything. Same after that, I have results. So I have all my tables in order. This is the outputs that I can use. So everything very organized. So yeah, if you want the file naming convention, we can develop, I think, something through Research Institute to have everything. I know a lot of organizations have very strict policies on how you file, how you name your file variables and so on. So yes, we can develop a SOP for it to be consistent.
Yeah, I think it's good practice even outside of stats. But thank you everyone for coming. And we're looking forward to having Sabina's part 2 next month. And yeah, thanks for your time today.
There we go. Bye, everyone.
Bye.